Today's resource person, Dr. Professor Srivastav, Professor in Chemical Department, Technological University, Pondicherry. He is an independent professor and researcher. About his introduction will be given by Dr. J. Srivastav. Now, I welcome him on behalf of all of you and our college. Welcome, sir. Next, I welcome all the participants. Thank you for your active participation. Welcome each and everyone. Now I invite Dr. J. Srivastav sir to introduce the resource person.
Good afternoon, everyone. Welcome you all for the second afternoon session of the day 5 for the FDP on the electric vehicle. I'm happy to introduce the resource person of the session, Dr. S. Jeevanandam. He is a professor in the Department of Electrical and Electronics Engineering, Pondicherry Engineering College. Related to his educational profile, he has completed BE in Benko Shillong Engineering College in 1998, ME in Power Electronics and Drives in PSG College of Technology, Coimbatore 2000, and PhD in the title Performance Evaluation of Innovative Control Strategies for Power Electronics Converters in Pondicherry University in 2008. His areas of research include PW strategies to VSI and MLA topologies, performance enhanced drives. He has secured first rank in his Master of Engineering and he is a qualified field during 1998 in electrical engineering. He has a vast teaching experience of 24 years in various engineering colleges. He has guided around 7 PhD scholars and 2 scholars. The research is ongoing, and he has guided around 28 MTech thesis and 27 BTech projects. He has more than 80 publications, including IEEE transactions, IEP, and elsewhere publications. He has published papers in 63 international conferences and 27 national conferences. He has also authored 3 textbooks, out of which 2 in Oxford University Press. He has also got 2 patents granted and 1 patent published. He has also visited more abroad countries like Singapore, Malaysia, Sri Lanka, Germany, France, and Netherlands. He has completed a few wonder projects. He has also held many other responsibilities such as Joint Director of Accreditation and Academic Ranking, Member of Centralized Admission Committee, and Program Officer NSS, Assistant Proceeding Officer JEC, and convener of Anti-Ragging Squad. He has also been the member of Board of Studies of 8 autonomous institutions and 4 universities. He has also delivered more than 50 international and national conferences. And we are delighted to have such an eminent person for this session. Welcome you, sir. Thank you.
Thank you, Dr. Jay. I also thank Dr. Beno for inviting me. I understand that participants may be from different departments. Just I like to know how many are belongs to every department. ECE, computer science. No. So triple and ECE. Any other department? Mechanics. So morning you had ID. Where you are born? Semi? Software. So I understand you may be a little tired and you had a heavy lunch also. But restrict yourself, don't sleep. This topic, the specialty is, maybe the title may say it's oral products, but definitely I can assure you, this is applicable to all field of engineering. Undoubtedly, mechanical, ECE. End of the session, you may appreciate, sir, this is applicable to my life also, my day-to-day life also. Okay. So then what is that? What is the beauty of this particular topic? What is that? Second life potential of electric vehicle power products. So thing is, using one instrument or one resource or one item for main purpose for some duration. After that, transferring it to some other usage where its capacity or its rating will be little less. That is the idea. Don't throw any resource or material or equipment in the dustbin. That's what I can tell you in short. Right? Daily or in daily life, we are using this concept. Right? So even toothbrush after 2 months, will you throw it or you will use it for cleaning your home? You are using what? Anything in your residence, you can recollect that. So many items are there. So here, the idea is power electronics. Past 1 week or 5 days, you have been, people have been telling about different topics in electric vehicle. In electrical vehicle, drive, design, or pollution control. So many topics they should have covered. Hybridization ratio and all should have been, they should have discussed. Everything is fine, but in any equipment, power electronics is important. What is that power electronics normally does? If your power is DC, it will convert to AC. If it is AC, it will convert to DC. If it is DC but it is fixed voltage, it can convert to LED voltage. So power converters, power electronics, we normally call them as power modulators or power processors. How the data processor in computer engineering, raw data in the back end, which may be displayed in the front end as a bar chart or spider chart or anything. That's what basically data processing. Like that, power electronic converters can process the power I'm giving. Like frequency can change, voltage it can change, it can regulate, it can vary, anything you want you can do. Correct? Correct or not? So power electronics will do that. Now the problem is the power electronics in this LED fitting, no LED fitting is there. So LED fitting like certain power electronic circuit is available. Power electronics is available in your mobile phone charger. Everywhere is available. Now the power electronics circuits available in these circuits, they will undergo very minimum stress. But the power electronic circuits available in the electric vehicle, they have to undergo no stress. They have to undergo no stress. You understand? What do you mean by that? Stress. Mechanical people can tell me. Stress, strain, Young's modulus, load by area. So for them, the stress may be in terms of force. But for electrical people, stress may be in terms of voltage and current. Voltage and current. Or electric field, magnetic field. Same concept. How much you are applying in a restricted area. That's what the stress. Now, again coming to the topic. So a power electronic circuit may be DC to AC converter or AC to DC converter, whatever may be. The converter which is designed for power electronics, electric vehicle. After 5 years or 10 years, I can use it for some other application like solar system or domestic applications or some other system where the stress is very less. Clear or not? Normally, young people will work in BAM or software engineering, software any field. After 61, they will say stress is more. I switch to business or some other job where the stress is very less. What is that idea? When I am young, I can handle any stress. But once got age, I cannot handle. Same idea. Is it clear or not? So what is that second life? The converters in electric vehicle application, they have been designed for higher stress over the period, after some period, instead of throwing them. They are not definitely at that stage. Those converters are not easily built. Okay? Negative stress. He is in negative stress. He is getting sleep easily. Okay? Your chair. Finally, okay. Oh, have you studied power electronics? What's your name? Sam Rajkumar. So, what is an inverter? Sam Rajkumar. DC. DC to AC. Correct only. So, if it is a 3-phase inverter, there will be 6 switches. How do you select voltage and current rating of the switches? Depending upon the. So, in inverter circuit, they should have shown in the previous sessions. Inverter. Input is DC, output is AC. 3-phase means 6 switches will be there. Single phase means output, if you want single phase, 4 switches will be there. Those switches normally BJT, MOSFET or SCR, those switches in electrons also you have studied electronics people. But in electronics you say it is they are signal diodes. Electronics we call them as, you may call it as a diode, but electrical people having learned power electronics we will call them as signal diode, signal MOSFET. But what is that name given to our devices? Power MOSFET or giant MOSFET. Giant. Okay, because your MOSFET and our MOSFET construction difference is there. Structure is not same. The doping level, that is a lot of difference are there. So they will handle 3000 volt, 3000 ampere torque. Your MOSFET, you will be using depletion MOSFET and enhancement MOSFET. But we will not use depletion MOSFET. For us it is useless. We will use only enhancement. We may not use JFET. Clear or not? And now power electronics people have migrated to wide arrangement semiconductor devices. You restrict yourself to silicon, germanium, etc. I don't know. But here people are talking about silicon carbide instead of silicon due to some advantages. Clear? Fine. Now the question is, if you download and check the data sheet of one device, it will be having voltage rating, current rating, frequency rating, then n number of ratings are there. dV by dt rating. dA by dt rating. Electronics people, when you teach operation amplifier, you used to teach them slew rate. What is slew rate? Rate of change of. Not sleeping. In operation amplifier, electrical people also equally responsible. You should also answer. Operation amplifier, so many specs we used to teach that. There will be a book called Jain and Roy Survey, in which very fantastically the nameplate data sheet is integrated into the text and parallelly the text will explain the data sheet. Am I right or not? I have never seen no author taught this subject like that. Even electrical machines, you can teach in that way. Nameplate details you can take and interpret the nameplate. You don't do that. Clear or not? What I'm trying to say is the power electronic devices, IGBT or MOSFET, they have n number of ratings. Now the question is, if a MOSFET, when I will simulate in MATLAB or SpeedSpice or say for any software, when I simulate, I will check the voltage across the device. If it is an inverter or rectifier, anything. When I simulate that, if the voltage across the devices comes around 100 volt, with a factor of safety, 100%, I will purchase the device 200 volt, normal. Clear or not? Again, how it is 2 times depending upon the application. In an electric vehicle, I may purchase up to 300 volts sometime. For other domestic applications, maybe 150 volt I will purchase. What is that? The capacity, what is required, and how much you are going to go, it is called. What is that? Sometime you need 1,000 rupees for the morning IV, but you are coming with 2,000 rupees. Extra 1,000 is what? Reserve. Correct or not? So here we call it as factor of safety. Factor of safety. So that factor of safety in terms of voltage rating, current rating, dV by dt, rate of change of voltage, rate of change of current rating, and repetitive peak, non-repetitive peak, lot of ratings are there. What do you mean repetitive peak voltage? The device will withstand that peak voltage once in the lifetime. Understood? Huh? That device, if it is a IGBT, maybe 600 volt 10 ampere IGBT, in which there will be a rating called non-repetitive peak voltage. That may be 800 volt. That 800 volt, once in the life it will withstand. Second time you apply, what will happen? It will die. Repetitive peak is there. So a number of ratings are available. Power electronics, process, credit power electronics. So now what I am trying to say is, when I choose the device for EV, I will keep this factor of safety for voltage, current, dV/dt, dA/dt, everything very high. But when I transfer to drives, motor, little less. When I transfer to solar system, still the factor of safety is clear or not? Again, you belongs to Nagarkoil, if you are coming out of your house, how much money will have extra? You are coming by two-wheeler. How much money minimum you can have? 100 rupees. Suppose you are 1 week you are attending a workshop in Mumbai. IIT Mumbai, you are coming out of hostel, wherever the accommodation is provided. How much money you should have minimum? Very good. Because factor of safety needed in Mumbai is more. In Nagarkoil, somebody you can call. Correct or not? That's all. Clear? Again, we will enter into the topic now. So what is that agenda? First we will understand, we will interpret the topic. I hope you have understood. Still, we will have some more slides to understand the topic. What is the topic? Second life potential of EV power electronics. Power electronic circuits available in electric vehicle. Once it is, they understand it is not suitable for power electronics age. Okay, right? The cricket, what is the age limit? Cricket players at what age they are playing? 40, 36. Some players may be little less. After that, what they do? What is the second life of cricket players? Coaching, commentator. That's all. So they are not. Sachin Tendulkar is not suitable for playing batting, but he is suitable for something else. That's all. So the power electronic circuit are used in the electric vehicle. Maybe after 10 years, they cannot withstand the stress because dynamic mode. Electric vehicle is dynamic load. Right or not? Understand? It has to undergo a lot of things like pollution, or it is exposed to atmosphere. Sometimes water may fall on the circuit. Sometimes when you accelerate, current will go very fast and a steep rise will be there. There it may not, due to aging power, it cannot be survived. But after that, it can be used for something else. So that we will study. Why second line for EV for power electronic circuit? PEC is power electronic circuits. And modeling of EV power electronic circuits we will discuss. Then reliability assessment methodology for converter packaging. They are little technical. I will restrict myself so that other department people will not get bored. Methodology for second line assessment of automatic power converters. This is useful for all department people. How it is being predicted. Some rules are available. Analysis and distribution of lifetime estimation. This the results we will discuss and the conclusion. Okay. Next. So topic interpretation. So second line potential. What do you understand from this? Is not visible, too small. What do you understand from this? Your name is that? Your name? Shamupri. Which institution? Chennai. Goa. Shamupri. So, sir.
Used throughout the separate forms.
So others will use of it. Okay. So here again the industrial process, how the things can be recycled and all I have done. Second line potential refers to the ability of a product or a component or material to be repurposed or reused after its initial life cycle, rather than being discarded or fully recycled. Recycling means yes. Right? So it is repurposed. This can significantly reduce the environmental impact and expand the value of resource. This is the definition. So the common examples. So this concept is everyone, because even it is not visible, we will not accept because you want to sit in the last row always. I know that. So is it visible? So please read. It is not visible. Still, you people don't want to move, right? Okay, so classroom Bandave and last student are even though they are faculty, most of them. So, wish you comfort. Right. So, next line. So, here it is first line use. This is second line potential. So, what is this? This one is first line use. And this is second line potential. Textile, electronics, shipping containers, lithium and batteries. Right? What kind of battery? Lead acid, lithium ion, sodium batteries are available, must be knowing. And textile, first line use, the fashion and retail clothing, you know that. Second line potential, recycle the fashion or installation. You can read what is this later. The typical words or terminologies or technical lingo, I have given explanation slides you can get. And rags means waste cloth. Electronics, laptops, mobile phones are first use. So the refurbished mobile phone, even it is available in the Amazon. Know that or not? Refurbished electronics items. Education tools, resale is available. And logistics, the containers are used for logistics. Otherwise, second piece is housing unit or pop-up shops. What is pop-up shop? Temporary shops. In festival and temporary festival, you can see pop-up shops. Lithium ion batteries, electrical vehicle, home energy, the first use. After that, you can replace the home energy storage and grid backup. Okay. So, a storage facility is again definitely in the picture. There will be a great potential for storage facility. You know that in grid there are sometimes off-peak hours power energy is excess. Power is excess. Peak hours we are in demand of power. Suppose you are a private vendor, you have storage battery. What you can do? You can store and you can give back the grid. This has some potential in future. Understand that? So whenever electricity, if you store and retrieve in the peak hours, it's a good thing. So here, the battery which is being used in electric vehicles, in the first battery is okay. AC batteries can be equal to home energy storage as well as spirit battery. Clear or not? Because here the stress is more. So here I have got the explanation for everything. All the insulation is the thermal insulation provided by the mechanical process will be knowing better. And benefits environmental, economical, consumer value, and brand sustainability. Environmental reduces waste and need for raw materials. Definitely, raw materials. Instead of throwing things, we can use it. And economic, create job in repair, refurbishing, rescale sectors. Job it will create definitely. And consumer value offers low cost alternative for consumers. Brand stability, company that promotes secondary programs gain priority. So here, some companies say you get my laptop after 8 years or 10 years, you return back to me. I will give you price for that, like gold or silver. So definitely it will have. You understand? So any product, why we go for branded product or even university, why you are going for a provision shop who is running for a long time? Because any problem is there, you can go and ask it. Right or not? Right. So what do you mean by this loyalty? A company, I don't know, I am purchasing a car, several car was there, Ford car was there, now both the companies are closed there, business in the India. Understand or not? So, but a company says that after 15 years, once your RC is over, expires, I will get your car back, huh? Company will gain loyalty or not? Say yes or no? All are sleeping, sir, no sir. So no is replying. This is a very tough topic. Okay. So I am reduced layer footprint. What is footprint? Footprint. Anyone of you? What do you mean by footprint here?
Emission of carbon dioxide.
Carbon emissions. Very good. So carbon footprint only is meant here mostly, but other is also there. Carbon footprint represents total amount of greenhouse gases. Primary carbon dioxide, methane, and monoxide, all they are flowing released into the atmosphere as a result of human activities. These images we go through later, we don't have time. And business in technology trend. Battery cell life, the Tesla, Nissan, and other EV are already they are repurposing their battery for grid storage. Right to repair law initiatives. I have some material for the law initiative also. Some countries have made law, but making it easier for consumer to extend the product lifespan. Right? And product as a service, it's a concept. So in entrepreneurship, when you promote any new product or any business, first they will be asking what is your business model. In entrepreneurship, they will be asking you what is the business model. For startup, there is a model called lean canvas. For established business, BMC, business model canvas. That business model canvas will be having 9 cells in which they will say what is your problem, what is your solution, who is your customer, what is the revenue, what are the expenses. This and that will be there. Clear or not? Clear? So in that, one type of model. So for example, we are using cell phone, prepaid mobile, or postpaid, or cable TV connection. That model is called subscription model. Monthly we are paying some money and we are getting it. Clear or not? There are some cases, one kind of model, there are about 50 models are available. There some model, main product rate will be very less, but consumable rate will be very high. For example, they say razor and blade model. Razor cost will be less, blade cost will be more. Again and again the person will. You understand or not? So like that, in that business, there is a software engineer maybe knowing it. Product as a service model. What is that? It's a business model where companies offers functionality or outcome of a product rather than selling a product itself. You are buying and purchasing 1 kg of apple. That apple, after paying it, that apple belongs to you. Whatever you want, you can say you can eat or you can give to somebody else or you can throw it away. You are purchasing a product. Clear or not? So here, you cannot purchase the product, the software, but you can use it. The outcome of the software you can enjoy. Customers typically access the product through subscription or pay per use, and provider retain the ownership. We cannot have the ownership like the example I told you, purchasing of Apple. In the case of Apple, after that, whatever you want, you can do. But here we cannot do that. And responsibility, they will be the responsible person for maintenance, upgradation, and end of the lifetime. So example for this is called software as a service, SaaS. Computer science people will be knowing it. So here, what happens is, it is they will be having a main server where the software will be available. But through cloud, you can use the software, right? And car sharing, renting the car service, furniture rental for function the marriage function, we are getting the furniture. Furniture we don't get the ownership, but for one day, one chair, maybe 10 rupees rent. Clear or then you have to return it. So that kind of model. Okay. Right. And digital twins used to track them, history and determine sustainability for second life application. What is this? Why I am telling all those things? So first of all, in the today battery second life already people have started. Okay. Here there are some countries they are making laws how to sell the second-hand car. Second-hand car when you purchase, some people may say that 6 months they will give guarantee for engine or 2 months they will give guarantee. What it are? Right? Like that, for those warranty, guarantee, and everything, some laws are made. And the second case, the product as a service cases, when you purchase the second case, you may be afraid how much year it will come. That case, we can go for product as a service. You need not purchase the battery, but you can get it for rent. And what is that digital twin? So it's a virtual representation of real world object or system used for simulation, monitoring, and analysis. So why it is needed? Your product first I sold as a first use, and I am monitoring the digital data I'm getting and monitoring it. Its behavior. If I monitor only, I can know whether it will have a second life or not. You understand or not? So here digital twin means really the car or two-wheeler is available. Its data, everything, model, I have the system. And day-to-day history. If you go to, you are purchasing a second car, if you ask the owner what he will say, it's a super car, there is no problem, no accident, nothing. But if you go to somebody who catch car to office, you check the number, what will say, sir, lot of accidents, so many clients, everything he will tell. Right or not? So, like that, all the history will be kept in the digital twin. It's a virtual replica of it. It acts as a digital counterpart to the physical twin and constantly updated with the data from sensor and other sources, allowing the real-time insight of it. Digital twin is needed for second life. So here, I am not giving any slide, it is not relevant. If you want to purchase any item for the second life, I should know the history of it. Understand? So the future, how it will come? They will ask you the history, digital twin, the model, and data, everything will give you. Then only they will purchase. So this and all technologically we have to take. Then next we have circular economy. What is that circular economy? Circular economy means it's a system designed to minimize the waste and maximize the use of resource by keeping material, product in circulation, circular economy, for as long as possible to process like reuse, repair, refurbish, remanufacturing, recycling. How many R's are there? 5 R's. Usually people talk about 3 R's, right? Remanufacturing, refurbishment, reuse, okay, repair, okay, refurbishment, I don't know exactly, remanufacturing, recycling. There must be difference. Can anyone try how to differentiate them? What's your name? Ranjit. Works of faculty. Which college? Thermopylae Engineering College. Oh, you are from Thermopylae. Okay. Government Engineering College. Okay, Thermopylae Government Engineering College. Some faculty, you are in the department. Some faculty from Atal University, they are educated. One Mr. Sativela. Yes. Okay. They come like our weekend there. I met him. Not another name. They'll show you later. Okay, he's there in your department. Satyvel belongs to EN department. Right, I will talk to you. So now you tell me what is the difference. Last month I met one faculty, he told the people from the company, he can be going to any idea? No. What's your name? Yes. Billy. Okay. Sorry, okay. Right. So my intention is not allowing you to sleep. Right. You move away from traditional take, make, dispose. What is this traditional dispose? Take, make, dispose. Purchase, use and dispose. Linear model, it's a linear model. To reach and here we are moving away from traditional linear model to a regenerative approach that aims to eliminate the waste and pollution, decouple the economic growth from resource consumption. What is this? Economic growth. So economic growth means what? Construction of building by removing the hills or developing roads over the water bodies. That's what happening now. Everywhere the development is going that way. Now, what you have to understand is economic growth means you have to consume the resource. You have to take the petrol diesel. You have to take minerals from the ground. Then only we can develop. But we can decouple. We can electrical people you must be knowing what is vector control. Sir, we have converted as ourselves to ECE or computer science, sir. Don't ask anybody to say. Yes. In induction motors, in DC motor, field winding separate current, armature separate current. Field winding current is responsible for flux, armature current is responsible for torque. But in induction motor, it is mixed, only one excitation. DC motor is dually excited. Squirrel cage induction motor is singly excited. One current. Some portion is going for flux, some portion is going for torque. We are the control which will separate torque component and flux component. There we say decoupling the current. I sin theta and I cos theta. Decoupling means separating. No dependency. Okay. So we have to decouple or at least reduce the dependency of economic growth on resource consumption. Okay. Sustainability is all coming from this world. This is what circular economy. You can see how the waste are used again. So nothing is visible, still you are happy. That's satisfied. Huh? Is it visible? Huh? So I never thought a seminar like this. Okay, but let's go. Okay, so this is what the cycle starts. Here it is raw materials, then design, then production, then distribution is coming, then consumption is there, then after consumption, repair and reuse is there, then again we are receivable is after repairing and reuse, still some waste is we have to do. Otherwise we will be using it. So that is the idea. Okay. Anyway, slides will be given. So circular economy in power electronics focus on design, manufacturing, packaging, power electronic component system, goal of increasing waste and increasing resource utilization throughout their entire life. So any product, you should have a habit. Any product you should not throw. Even a screw in that, anything you keep it in your box, definitely one day it will be useful. That's what the main point you should carry from this session. Any item, a piece of PVC pipe may be useful another day in your house. That's the idea. So because you don't think that as you have purchased something, you are the ultimate authority for the thing. You cannot simply purchase and waste as you have money. You should reuse it so that definitely it will help for the sustainable development. This involves strategy like designing for durability. During the design itself, I have to make a component with more durability. Rather than putting road in every election with low quality, make a good road. It may sustain for 10 years or 20 years at least, right? So that in order to take blue metals again and again. So that is the idea. Durable design, recycling, reuse, implementing efficient end of life management process practices. End of life So this end of life management practice, this you are right. This is very common to all engineering. You just write these keywords and browse end of life management plus IC engine, you may get some material. Right? Or model, you may get some material. Right. So here, again, is it visible?
No.
You come friend. You know, at least students you come friend. Go back. Sir, baby sir, நீங்க வாங்க. தர்மபுரி நீங்க வாங்க. நீங்க வாங்க ஃப்ரெண்ட்ல வாங்க. So if you attempt and answer my questions, I'll give some gift. Nice. Yeah. Normally, I believe that those things record is passion. That's the reason I need to want very simple. Like now everything okay? Will you proceed? No, sir, yeah. Not visible. Okay, I will read. So here, so this is linear economy. What is linear economy? Take and dispose. Purchase, use and dispose. This is circular economy. So here, what is that? Raw material is sourcing. Raw material is sourcing, production, using phase, then going to the desktop. So here what happens? Circular economy, the circle flow. So here, lot of interlinkings are there. You should be very careful to understand. So here, the primary raw materials are there. In primary raw materials, some losses will be there, right? Primary materials or losses will be there. Na? In example, you will feel primary raw materials, some losses will be there. What is that?
For me,
Now, some examples are there. You are purchasing vegetables for the house, maybe once. Okay, beans, carrot, everything. All 1 kg na 1 kg you purchase 1 kg you can cook. Wastage will be there na. Simple example. After that, raw material sourcing, then production is there, distribution is there, production losses are there, distribution losses are there. Then using phase, again some losses will be there. Then after the using phase, repair, reuse, and all you have to try first. If it doesn't work out, then you have to collect. Then it goes to end of life management. Okay, what is that? Maybe raw material, so getting raw material, production, duration, use phase up to that. Okay. After that, here some loopings are there, repair, use. Like costly items, we can repair. Okay, you should think maybe some 30 years back, lot of items there are people to service. Now today we are not servicing. Even the pen 30 years back, what normally you do? We will do. Now, so clear. Small speakers, we will be there to change the paper, oil, everything. Today, no one is there. No one knows that. So that is possible to repair and reuse. Then, if it doesn't work out, local no serviceman is there, they will be you have to collect it. There should be law for getting those things. Then, again, next stage is remanufacturing and refurbish. This difference is all like then refurbish distribution goes, again use it, again repair, recycle, again it will come. Okay? Then, end of life management means that's what our second life potential comes. Okay? Then it may be given to the manufacturing plant, again it will be. Okay, so this should be the way the source returned into the product cycle at the end of the life. Okay, so this must be our management in all, right? Even the food, any garment, anything, we have to stick on to this. Then only the country, very populated country, can sustain. What is the difference between remanufacturing and refurbishment? Let us see, because recently you must be knowing remanufacturing and refurbishment are both process for restoring used product, old product. But they differ significantly in their scope and intensity. Remanufacturing involves more comprehensive process of rebuilding a product from its individual components. So individual component I will say take and I will change something like that. But often incorporating reuse, repair and new parts to meet out or exceed the original specification. Sometimes what I will do is I will try to repair all the components in the laptop, hard disk, motherboard, RM boards, ports, everything I will try to. நீங்க தான் டைம் செட் பண்ணி வச்சிருக்கீங்களா அதுக்காக so sometimes new parts are laptop you have given to me I feel that for today's operating system it doesn't work so what I do is RAM old SDRAM is there I will keep somewhere RAM DDR RAM or whatever like this I don't know so I will replace that is all going in my mind refurbishing on the other hand less intensive process and typically focus on repairing this product to the functional state. Here, sometimes I go to exceed the original specification, right? I will change the processor from 3 GHz to 20 GHz, i3 to i5, and I will upgrade and remanufacture. I will 80% I will use the old components, but I will change some new component. Sometimes the possibilities there will exceed, clear? But here, refurbishing is not so. Often by addressing specific part without necessarily replacing all old parts. New parts will not be added. Clear or not? What is this? If you search, you can see refurbishment, mobile phone market. If you search, you will get all those things. Amazon's great, like Amazon Fresh, they have works great. Second topic. So, have you understood the topic of presentation? Everyone? Mobile is not allowed, right? That is for some other purpose I will show. Okay, you tell me what is the topic? What is the significance of topic we have to say? What's your name?
Leo Boscoras.
Leo
Boscoras.
Leo Boscoras. You are from this college. Okay, tell me what is that you have understood?
So, second time is we will reuse the packet.
What is that? I am trying to tell you is any product or any material. Yes, it is purchased for some purpose. After some days, it may not be meeting the requirement for that purpose. Some other lesser purpose it can solve. Clear? Okay, yeah. That is the idea, right? Why second life power electromotive? The newer generation of electric vehicle market go to market more electric vehicles with out of use components fully electric. So as electric vehicles are getting more into market, definitely their components will e-waste like e-waste, EV waste will also become. Some of these electric vehicles will have component that no longer pass automotive standards. Automotive standards for India, automotive industry standard AAS 74. This is released by Ministry of Road and Transport. They are issuing. Like pollution standard is there. So free break no so you have to check him. Our idea okay, so it's something they will not. I am not good at the standards, but standards are there for every country. They cannot meet their standard. Okay, so assessing the second life potential of end of life action for converters, repurpose for stationary application. This dynamic or mobility application is EV, but stationary application it is maybe suitable. Okay, like solar energy conversion. Today we are going to discuss about how it can be used for a solar energy conversion. Traction converters in electric vehicle are subject to aggressive emission profile as the vehicle can go from idle condition to full power acceleration and such power condition within the second. You will accelerate. The driver will decide how things are to be done. So the converters, whenever you accelerate, in a IC engine fuel, we are injecting more to the carburetor where it will mix with the air and it will be burned in the IC engine chamber. But here everything is current and voltage, correct or not? Right? Voltage is which current has to take more. So to more power, current has to be taken, not more. Hence this traction converters experience electrothermal stress profile that degrade the electrical and thermal impedance of models, thereby reducing the efficiency. What is that thermal impedance? If anyone answer this, we will break for tea. Heat is heat. Thermal impedance or thermal resistance is what?
The loss of
Loss of power. Heat. Okay. Partially done, sir. What is the unit for thermal resistance and impedance? Some unit will be there, degree centigrade, something like that. Joules. Any one of you? So its unit is degrees centigrade per watt. Can you anyone give the definition for the unit? Unit definition for unit, we should be clear. Degrees centigrade per watts.
Change in temperature by energy power.
கொஞ்சம் பிராக்டிகலா சொல்லுங்க. கரெக்ட் தான் நீங்க சொல்றது. பிராக்டிகலா சொல்லுங்க. இப்போ நாம வந்து thermal resistance is something like maintaining the temperature of the machine. Electrical machine எடுத்து. Electrical machines we have got insulation class B, we have class 120 வரைக்கும் beta 135 னா H இதோ insulation ஒரு 5 டைப் பண்ண போட்டுருக்காங்க. So நாம வந்து purpose என்ன binding in electrical motors, which component is badly affected by heat? Induction motor ஏதோ motor தெரியும். Rotor, shaft, coil, slot, core, which one is much affected by coil? Why so? Because you know that at rated condition or maximum efficiency very close to that, copper loss should be equal to core loss. Core loss and copper loss are more or less equal. Both are producing same amount of heat, but to accept the heat, core is big in volume, copper conductor is small. Again, another disadvantage is copper coil is kept inside some cave. It cannot dissipate. Conduction, radiation, nothing will happen. So heat will increase. So thermal resistance, insulation, thermal resistance, degree centigrade per watt. How much temperature it allows to increase per 1 watts of power it loss. So இப்போ உங்களுக்கு ஒரு மெக்கானிக்கல் இன்ஜினியரிங்ல ஒரு பாடி இருக்குது, அதை பாலிஷ் பண்ணீங்கன்னா thermal resistance என்ன ஆகும்? பாலிஷ் பண்ணா என்ன ஆகும்? ரேடியேஷன் அதிகமாயிடும். அப்போ thermal resistance கம்மி ஆகும். தெர்மல் இதே மெக்கானிக்கல் இன்ஜினியரிங்ல எலக்ட்ரிக்கலையும் பார்க்கணும், ஃபில்ம்ஸ் வைக்கிறாங்க. அப்போ பாலிஷ் பண்ணும்போது thermal 3 waysல we can transfer the heat to the atmosphere: conduction, convection, radiation. பாலிஷ் பண்ணா ரேடியேஷன் அதிகமாயிடும், thermal resistance கம்மியாகும். ஃபில்ம்ஸ் பண்ணீங்கன்னா ஒரு பாடி நார்மலா ஃபிளாட்டா இருக்குது, அதுல வந்து அப்படியே ப்ரொஜெக்ஷன்ஸ் இருக்கு. இப்படி why?
more area.
Yes, very good. Conduction area is more. So அது கண்டக்ஷனா கன்வெக்ஷனா?
Opposite conduction and outside, because outside is conduction.
Fluid இருக்கிறதால கன்வெக்ஷன் சொல்லலாம். So area, air வந்து டச் பண்ணக்கூடிய ஏரியா ஜாஸ்தி இருக்கும். Okay, so thermal resistance, that's all. So the devices on the thermal resistance, heat transferring capability will decide aging up. Okay, so we break it down. அதுக்கு இந்த தடவை ஒரு காம்பினேஷன் டிஏபி ஒரு கிலோ, யூரியா ஒரு கிலோ, பொட்டாஸ் ஒரு கிலோ, மைக்ரோ நியூட்ரியன்ஸ் ஒரு கிலோ, கார்பன் ஒரு கிலோ, இம்யூனிட்டி ஆசிட் ஒரு கிரானுல்ஸ் அது ஒரு கிலோ. இதை வாங்கி பாண்டிச்சேரியில வீட்டு உபயோகமாக இருக்கு. அது வச்சு அது வந்து நம்ம சோப்பு பச்சை வேணும் யார் வந்து அஜித் இருக்காங்க இப்போ தெரியுமா அது இந்த காலத்துல அஜித் போஸ்டோ அஜித் போஸ்டோ தான் நினைக்கிறது நல்ல காட்சியில இருந்து ஒரு 3% காய்க்கிறது அப்ப இந்த காம்பினேஷன் போட்டு கழிக்கிற 3% அதனால நாளைக்கு ஒரு அரை கிலோ போடுறோம். அதாவது மாண்டியவர்கள் ஓகே அதனால செம்மணி கூலி எல்லாருக்கும் ஓவராக இது வந்து ஈஸியா சில
கூலி வேலை செய்யறாங்க பெரிய நீங்க அந்த வெற்றி
ஒரு தடவை ஒரு 16 சென்ட் அடியே ஆனா முதல்ல கல்ல நம்ம படிக்கிறேன் அடிச்சா தெரியும் தூக்கி வண்டியில கொடுத்துருவோம் 17,000 கரெக்ட் அப்படியே சுத்திட்டே இருக்கும் ஓட்டிட்டு டயர் இருக்கும் ரெண்டு கால் தூக்கிட்டு ஆக்சிடென்ட் அது வந்து அந்த டீப் ஆகி கேட்டோம் வேற ஒரு லிட்டர் ஒன்று கூட வரும் 16 சென்ட் அதாவது பசங்க ஸ்கூலுக்கு நல்ல பேர் சொல்லுவாங்க ரொம்ப நீங்க காம்படிஷன் நீங்க வந்து நாளைக்கு ஸ்பென்சர் அவங்க முன்னாடி ஒரு 5 வருஷம் முன்னாடி அப்புறம் பிரசன்டேஷன் இன்டராக்ஷன் பண்ணுவாங்க, மெயில் அனுப்புவாங்க, பயங்கரமா இருக்கும்.
மேக்ஸிமம் அடல் ப்ரோக்ராம் நிறைய இருக்கிறோம் ஆன்லைன் சர்வீஸ் நம்ம தான் நான்
அப்படி இல்லை சார், இங்கே கொஞ்சம் ஆளுங்க இது பண்ணாங்கன்னா
கண்டிப்பா அட்டன் பண்றோம். ரெவென்யூ சர்வீஸ் பண்ணி ஒரு சிங்கிள் பண்ணிடுவாங்க கண்டிப்பா அட்டன் பண்ணி அதை வந்து டெஸ்ட் வச்சு செஷன் பண்ணுவாங்க. அப்டேட் கொடுத்தேன்னு வச்சுக்கோங்க. இப்ப அதுக்கே சார் இல்ல Okay, so let us continue the second heading. Second thing like why second like for ED or what does that consider unusable anchor electrical and thermal impedance of the model increases by at least 20%. So you know that like gold or silver some current value is there 22, 24, some low value the price will be less. Like that here for power converters the thermal resistance. Thermal impedance or resistance, the unit is degree centigrade per watt. Its value goes below then we cannot use for EV application. Okay, so that is the index or matrix to reject from the EV. It's ideally should occur after vehicle useful life. Definitely, let's say that electric vehicle is 15 years old, 15 years old or electronic converters associated with the electric vehicle will come. After that, where you have to replace and use it for some other purpose. However, suitable derating in less stressful stationary application. End of life traction converter. Yes, traction converters are nothing but converters used in electric vehicle. They are end of life. Now they can be moved to less stressful, less voltage, less current, less deliverability, less reactivity. What are they? Rate of change of voltage, rate of change of currents. They can be shifted to still have a air efficiency available. So they may show you 90%, 100%, 99% efficiency for stationary application, but they will not give you efficiency for traction application. Fine. What do you mean by derating? Anyone of you? Derating. What is rating? What do you mean by rating? Rating. You are giving some value to the channel. For example, BHP rating, mechanical engineering, you say BHP, break-off power rating. For two-wheeler car, is there or not? Yes. There is a rating. Then, for example, the CFL light can be 20 watts or 30 watts. So power rating is there, current rating is there. That is rating. Then what is derating? The verb derate means what? Reducing efficiency of the, not efficiency, value of the.
Positive, maximum.
Yes. Power is 30 watts now 28 watts or 25 watts. Everything we are reducing, degradation or derating. Derating means continuing in the usage with less capability. With less capability. The ex-serviceman now he is working as a watchman. Now he is not capable of handling weapons. Now he is sitting as a watchman. Understand that? That's all. So derating. And however, it's complicated. Using electrothermal simulation and reliability modeling, this study demonstrates that 300 kilowatts traction inverter with 20, 40, 60 high thermal electrical impedance. So here the inverter for traction 300 kilowatt is tested with 20%, 40%, 60% thermal impedance changes. They can offer 98.5% efficiency when they are using solar inverter. I don't think that as it is second life from electric vehicle to solar inverter, efficiency will go down. Efficiency for solar inverter is good only. Ex-serviceman as a watchman is doing well. The directly recruited watchman compared to that, ex-serviceman will behave better. But again, after retirement, still he is continuing in the army, he cannot do that. Correct or not? Yeah, retired army man can be a good watchman than us. Because directly he has undergone all the pain and process. Here are like that. Here, with inverters for traction, they have been designed with higher capability. So that's the reason, even after the first line, it is doing that. So that's what the main analysis here. As new generation electric vehicle, okay, fine, I told already. This EV will contain traction converters that although may no longer be usable in automotive systems or traction system electric vehicle, may still be usable in stationary application. This is what the bottom line. Given that electron waste has been cited as a fastest growing stream of the solid waste, e-waste is the threat to us. This is the main solid waste. Incorporating circular economic principle in design of EV component will increasingly become important. So, like other solid waste, e-waste, it does not go like that. We have to recycle. So, EV traction converters are critical component that convert DC power from the battery into AC, which will be given to the motor drive motor. Historically, traction converter has been implemented using silicon-based IGBT. However, recently, silicon carbide MOSFETs are replacing this. The silicon carbide are gallium arsenide. They are called as wide energy band devices. Electronics should have studied conduction band, valence band, gap will be there. There is a class of semiconductor material called W wide band gap semiconductors. Silicon carbide comes in that category. So silicon can withstand minus 50 degree to 155 degree centigrade, but silicon carbide they can withstand 300 degree centigrade. That is also important. So that is what we have seen. So as silicon carbide MOSFETs are extremely doing well when compared to IGBT, what they will do? It will throw IGBT from electric vehicle. That can be used for some other purpose. There may be soon an increased disused silicon IGBT based traction converters. Same car, same bike, but the inverter they will throw because it is IGBT based. I need instead of IGBT, normally IGBT is a high power, high voltage device when compared to MOSFET. When you comparison with weak on device in the MOSFET. Next BJT, next IGBT, then IGCT. After MIT, MCC, lot of devices, and then finally comes GTO, IGBT over GTO. Final SCR. SCR is a fellow who can withstand more current, more voltage. Power, current and voltage more, power is more. But powerful devices, their switching frequencies is less. MOSFET is having high switching frequency. On and off, I can do in megahertz. 200 megahertz MOSFETs are there. Power MOSFET. I'm not talking about MOSFET used in electronics. So any power element device, high power means frequency operation will be less. But today, even though by concept MOSFET and IGBT, MOSFET is a low level device, high frequency but low power device. IGBT is moderate frequency high power device. But with silicon carbide, it is doing well. So people started throwing the silicon based IGBT converters from the EV. So that based converter will come. This important aspect in design of traction converter is thermal management. How normally a thermal system will do? In the IGBT, anything is there, this kind of heat sinks are there, springs. They are called as exclusion heat sinks. Heat sinks again, a lot of types are available. This is one kind. So here, over the heat sink, there will be a thermal insulation. There will be a base, base will be put. When is thermal conductivity? Copper will be there, again ceramic layer will be there, again copper, then the device will be placed. This is what now people will arrange. So what is that thermal impedance? How to understand thermal impedance? So any power electronic device, IGBT, MOSFET, I can draw equivalent circuit like this. What is that equivalent circuit? In electrical engineering, when you teach first years, you will be teaching them simple DC circuits, right? Circuit theory. Am I right? No one is saying electrical and electronics people will be knowing. So there will be a source. This is series circuit. Right? 1, 2, 3, 3 resistance and one source. This is DC series circuits. Right. So in that, this is normally used for current source. Source level, voltage source is there, current source is there. Then both voltage and current source, dependent source is there, independent source is there. So this is normally current source. So here and this is active element, these are passive elements. Meeting point of two elements is called node or junction. This attempt to represent the thermal system in terms of electrical component. Some analogy is there. So here, in a device, this is a power IGBT heat sink. There will be 4 losses: conduction loss, switching loss, gate loss, reverse leakage loss. There are 4 losses. In a motor, what are the losses available? Copper loss, core loss, mechanical losses. In core loss, hysteresis loss is there, eddy current loss is there. In mechanical engineering people, there will be what are the losses they have? AC engine, friction loss. Thermal loss. Another loss. Air friction is released. There is also fluid friction. Friction loss. Only one loss. Torque loss. We are talking only about power loss. Okay. ECE process, you tell me what are the losses you have associated with the system. In communication, sideband so many losses will be there, suppressor carrier. So, in any system, losses will be there. Losses will waste the power as a heat. Right? Understand? So, here, all the losses, 4 losses I told you, those loss are representing the current source. So, what happens? Power loss is taken as current. Power loss is taken as current. So, current flows here. Okay, so what is that? You assume that power loss. It's a heat only. It's a nothing but heat only. Power loss will cause a heat. So first what happens is inside the device, semiconductor junction will be there. PN junction, PN junction is there, na? Correct? But here multiple layers are there. That point is called junction. Temperature at that point is TJ or T junction. After junction, next node or junction is after. You understand? Node or junction is what? Meeting point of any two components. So in the first enter node device or semiconductor internal component point. Next one the case. Any device, semiconductor device, there will be a case. BJT level we get the metal cap. BJT SL100 or BL 106, these 106. Let me remove package. Plastic metal cap. It is called metal cap. There are D18s. You know, the ICL also. So எல்லாமே பேக்கேஜ் இருக்கு. மோட்டருக்கு வந்து எலக்ட்ரிக்கல் மோட்டருக்கு என்க்ளோசர் டைப்ஸ் இருக்கு. அதான் கம்ப்யூட்டர் தமிழ். Any Malayalis? No. So electrical motors have got types of enclosure. மோட்டருக்கு மேல இருக்கிற கவர் இருக்கு இல்லையா, அந்த டைப்ஸ் இருக்கு. இதுதான் இல்லையா? Indian standards are there. IP standards சொல்றாங்க தானே. So from today, any topic you read, any subject you read, browse the standard. எல்லாமே ஸ்டாண்டர்ட். IP standard என்ன? Industrial standard. Ingress protection. Ingress means allowing external properties. இப்ப LED light, street light எல்லாம் பர்ச்சேஸ் பண்ணீங்கன்னா IP65 போடுவாங்க. உள்ள தண்ணி போகாது, வாட்டர், ரெயின் வாட்டர் போகாது. ஓகேயா? சோ இப்ப கேஸ் இருக்கு, எல்லா டிவைஸுக்கும் கேஸ் அந்த கேஸ்ங்கிறது ஒரு பார்ட் எடுத்துக்கோ, மூணு எடுத்துக்கோ. அப்ப இந்த ஜங்ஷனுக்கு கேஸ் கிடைக்க ஒரு டெர்மினேஷன்ஸ் இருக்கு. திஸ் கால் RTHJC, சஃபிக்ஸ்ல JC போட்டுருக்காங்க. ஜங்ஷன் கட்டு ஹீட் சிங்க் வெளியில தெரியுது. கேஸ் internal point is semiconductor junction, then you have got case packaging, then sim க்கு case கிடைக்க there is a thermal resistance. Thermal resistance, what is the unit? Degree centigrade per watt. Okay, this is electrical network la voltage source இருக்கும், current will flow, one junction, next junction, it resistance in ohms will be present. Okay, what is ohms law? V is equal to IR. So we compare பண்ணீங்கன்னா some voltage will be dropped here, again drop, finally all three components will consecutively drop the voltage. Correct? Potential rise, potential drops. இங்க instead of voltage you have to assume, instead of current you have to assume power is flowing. So இங்க வந்து voltage பதில் you have to assume temperature. அப்ப ohms law எழுதலாம், time temperature is equal to what is I here? Actually power loss. So temperature degree centigrade, resistance degree centigrade per watt. This I is instead of I should put power actually watts. Watts and degree centigrade per watt cancel temperature. So like similar to ohms law, here I can make a law like this. Temperature is equal to heat into power loss into thermal resistance. So next என்ன வருது? Ambient atmosphere. Between that there is a, so internal junction to case resistance manufactured to the same. Case to heat sink also manufactured to the same. But heat sink to ambient, this I can change. Heat sink I can change. Okay, total thermal resistance you have to add everything. So total, so here I have to make problem. Power energy calculates with power dissipation 50 watts. How much power is wasting? Heat, how much heat is producing? 50 watts. Ambient temperature is 30 degrees centigrade. Right? Total thermal resistance. Actually, junction to ambient. In first cases, junction to case, then case to sink, then sink to ambient. Value of is given 0.4, 0.1 and 1. Totally 1.5 degree centigrade per watts. What is the junction temperature at steady state? What is junction temperature? Temperature of the internal semiconductor material. How to calculate simple thing is junction temperature TJ. This temperature is very good. Voltage at this point is voltage at this point plus drop, this drop plus this drop plus this drop. Correct or not? Voltage at this point. One node will take as reference node. Circuit theory என்ன பண்ணுவோம்? ஒரு நோட் என்ன பண்ணுவோம்? ரெஃபரன்ஸ்ல இருந்து எந்த பாயிண்ட் கேட்டாலும் ஆட் பண்ணிட்டே போவோம். இங்க ரெஃபரன்ஸ் இஸ் ambient. So like that, junction temperature, internal temperature will know. Because semiconductor material will work, silicon will work from 50 to 150 degrees centigrade roughly. But 175 nowadays people are arguing. If junction temperature goes above 175, what will happen? Device will. So BJT la if you have studied secondary breakdown, thermal conductivity, that kind of things will happen. Okay, so now how to calculate ambient plus power into first resistance. Power is like that. Power into this all three resistances you have to multiply. So 30 plus 50 into 1.5. What is 1.5? This thermal resistance, this all together 1.5. I'm getting 1.5. So but device can distance limited can distance up to 175. Normally we operate below 150. Clear or not? This is what the meaning of thermal resistance. Okay. So power rating of converter needed for typical domestic solar energy conversion systems are significantly smaller than those needed in automatic selection application. For solar, the rating is less only needed. Where the D rating, you know, D rating you can be like. Right? What is our aim? Borrowing the inverter from the electrical vehicle to the solar system. For example, typical electrical reaction converter will have power rating of 60 watts or 300 watts. Whereas solar is very less. So they are suitable for the second time. Vehicle end-of-life batteries, again, some variants are there. This is a policy initiative from European Union that sets ambiguous targets of reducing recycling material used for new vehicles. Right? And European countries like Germany, France, even the election manifesto, the political parties started telling about all those things, sustainability and all. Not like us. If you come, we'll make bus free or monthly, those people, it's not like that. They say we'll remove all the traffic conversations. Like that, they started talking. So, once Europeans were very bad, they were routing all those items from Asia. Now they are doing very reasonably good, and they are talking about sustainability. So, hence, second line exploitation of EV for electronics can contribute not just this initiative but also reduce the electronic waste. So, what is that objective? To establish theoretical framework for quantifying the efficiency like the second automatic production converter. What is that we have to do? We have to test whether it is the converters are good for the second line. That's what must be our objective. There are currently no established methods for accessing reusability of EV power transmitter. Not this field is imminent. Still, methodology should be evolved, right? So we have to have make. I mean, if you want to do research in this area, maybe in power or this area is reasonably good. Modeling the converter as a fresh is different, but age converter modeling and prediction of their potential for the second line is different. The approach for remaining electrical model of power devices. Why electrical model? Because the quality or the healthiness of the device is evaluated based on thermal resistance. So the electrical model is important. What is the electrical model? This is a single pair model, but there are complicated models available. So representing a thermal system in a RC network, R network actually capacity will come. I removed it because each node has a capacity. Capacitors. Capacitor in electrical engineering here, and capacitor will tell you capacity to move. How much temperature it will withstand. Okay. Like that complicated thermal models are there, and one has to go through. Okay. Packages based on machine and data sheet parameter, well established reliability model from decades of cycling experience. So we have to test conditions. By varying average indicators, like what is that? Who is the indicator? Normally KPA. What is KPA? It is very common terminology in different engineering. What is KPA? Key performance indicators. So here key performance indicators are thermal resistance. These three girls are very happy. Your final years are. Final years. Why you are very happy? Got any lottery? Lottery is banned again, na? What's your name? Aarti. Kartika. Kartika. Oh, mixed. Aarti and Kartika mixed. So, two names mixed and new name has come. In English, adding two words and making new word. It is called as breakfast and lunch. Yeah. You are making what is that word? Lunch. Combining two words and making a new word is called as what? Today we are going to search, okay? Right. So in the pro, if you laugh, you will have to read. Okay? I need break. Right. So this is important for incorporating circular economic principle into supply chain of renewable energy system and can be critical in application where process critical, for example, renewable energy systems in rural communities. If it can be demonstrated that end of life automatic power converters can be repurposed for renewable energy systems. It can solve the real problems of electronic waste and low energy, low cost energy generation. Contributing the human sustainable development is the key goals. How many goals are there? 17 goals. They started in 15 and they have the deadline of 30. Goal 7 and 12 I feel is suitable for our area or discussion today's presentation. 7 says ensure access to affordable, reliable and sustainable water energy for all. So So when you talk about energy for all, we have to be very economically. Sir, give me sir. Okay, sir. Or we have our answer over there. Okay. So second, another goal is ensure sustainable consumption and production patterns. So these two goals we can achieve with circular economy. You are not as are not allowed to. Okay, don't start. Okay, then so here the modeling comes. So in couple of slides I will capture everything. Therefore, the model for EV traction converters is first step that will help you in predicting the potential second line. Okay, so here typically electric vehicle PMS, thermodynamic exposed motor. So it is normally it is controlled by vector control or field oriented control. I told you already. So here what will happen is three-phase current A, B, and C phase current. They will be converted into two-phase current using clock and path transformation. Then the control will be done. Three-phase current will be sinusoidal, but when you convert to two-phase rotating current, it will be DC. Sinusoidal current will become DC, so here the control will be very easy. That's what we are being done. And this is a typical system from where we have to work. And major component thermal network will give you temperature. And from the converter, we can estimate the power loss. Power loss is spread to the thermal network, will give you the temperature. Temperature is exceeding, we have to stop everything, otherwise the converter will get die. Okay. And here, motor model is there. Motor parameters like resistance, impedance, inductance. All those parameters will be given to system so that component quantity, speed, torque, everything will be controlled, and based on that, gate pulse will be generated for inverter to control the motor. And it's the basis of inverter control. Today, we cannot cover. So this is the equation for converting power to clock transformation. It's a matrix-based conversion system where three-phase stationary quantity can be converted to two-phase stationary. Two-phase stationary can be converted to two-phase rotating, synchronously rotating. Okay. And this is the typical data sheet of IGBT. It's by all semi. There are so many companies like SVC, IRF. Here it's a all semi converter. So this is the IGBT number NGBT 50N60 FWG. You can interpret everything. 60 means 600 volt, like that you can interpret. It's interesting. It is a part time, it's not simply given. And here, collector voltage, minimum collector current, TC, and temperature, 25 degrees is current, 100 degrees is current. Lot of equations are there. Its dimensions are given, and so many thermal characteristics are given, right? Its characteristics will be given. It's a 5 to 8 page data sheet. How the current and voltage will balance when you turn on and turn off. Right. So this is what people will provide a data sheet. So first step is you have to model the system thermally, right? And when you to model it, you have to use some drive cycle. Driving cycle in various cases we have told. No, what is driving cycle? For example, if any product you manufacture in the plant, there are two types of tests. One is type test, and one is routine test. What about it? Mechanical people must know this. Type test. For example, for Tata, they make Tata Punch new car. 2-3 years manufacture. So it is a new model they are launching. For a new product, they have to test fuel economy and stress, everything they have to check. That is a type test. Once the pass age, 5-star rating they got. Now they are making 1 lakh or 50,000 cars. Every car you have to test. It's a complete test. New product, first time you have to do type test. Electrical engineering, insulators, conductors, switchgear, everything they will test. That is new item they will test. Type test. So it is very basic, deeper level. Testing is very test. Okay. So here. For testing this electric vehicle, I told you, modeling and this is past, modeling. There are some life cycles. Image processing, electronics, that are open data are available. அது எடுத்துக்கிறீங்களா AAA ஸ்டாண்டர்ட் எல்லாம் அவைலபிளா இருக்கு. Like that here the new European tricycle ஒரு அர்பன் ஏரியால 120,000 seconds டிரைவ் சைக்கிள் உங்களோட வெஹிக்கிள் எப்படி டிரைவ் ஆகும். அதுல பாத்தீங்கன்னா 780 வந்து அர்பன் டிரைவிங்கா இருக்கும். அப்புறம் 780 ல இருந்து 1000 வரைக்கும் எக்ஸ்ட்ரா அதாவது சிட்டிக்கு வெளியே. அண்டர்ஸ்டாண்ட்? நான் வந்து இப்ப லேப்ல டெஸ்ட் பண்ண போறேன் என்னோட எலக்ட்ரிக் வெஹிக்கிள். அப்ப நான் என்ன ரோட் போடுறேன். இப்போ எலக்ட்ரிக்கல் மோட்டார் லேப் எப்படி டெஸ்ட் பண்றோம், பெல்ட் போட்டு டெஸ்ட் பண்றோம். பட் ரியலா எப்படி எலக்ட்ரிக்கல் மோட்டார் ஒர்க் ஆகுது, பம்பிங் யூஸ் பண்றோம், கிரைண்டர் யூஸ் பண்றோம். பட் ஒரு டெஸ்டிங் பிளாட்ஃபார்ம் என்ன பண்றோம், பிரேக் ட்ரம், பெல்ட். Artika, how do you test load test, conduct load test electric motor? How do you load the motor? You are an electrical student. How do you load electric motor? By? What's your name? Janisha. How do you load the motor? Brake drum, belt, spring balance, everything will have. But really, in practical situations, whether they are loaded like that? No. Testing purpose we have that. Like that we have. These are typical 1200 seconds. 1200 seconds means how many minutes? 20 minutes from one. Okay, these are the test panna. So here batteries are from DC to AC conversion in order to be done. Here IGBT planar and sponge. The channel is looking on different area, right? Different type of IGBTs are used. Normally 10, 15, 20 IGBT. One IGBT is 6 amps. It takes 6 amps. In case of one IGBT, normally you have 10, 15 IGBTs. IGBTs are not available, cheaper and far higher. இது வந்து சப்போஸ் 300 amps இருக்குன்னா ஒரு பேஸ்ல 300 parallel replacing IGBT எவ்வளவு bus okay so now we are going to so instead of when one day purchasing IGBT with some packets are going up anyone student which students are your packet yeah you go to your friends. How is this going to start? Okay. Okay, now they are studying that. So IGBT depending upon the construction or structure there are different types. V group, M group, other separate area design of IGBT. So in the particular case study we have used this IGBT. And what they have done is they have done different results like temperature, power, current, torque, speed, at two different places. Low torque and moderate speed, full power acceleration, right? For new inverter and old inverter. Okay. So what is our idea? Secondary potential you can talk about. The results are available here. Right? So they understand that when they vary the thermal resistance, definitely the efficiency goes less for acceleration testing. The second test is acceleration remote method. Okay, power other way, torque speed like that. So in that case, our performance was star. But for stationary, first case it is doing well, even the old inverter. So like that, based on the NEDC, different tests are performed in terms of speed, torque, and current, everything tested, and they have restricted their testing within 170 degrees temperature. The whole which is not allowed, and they have done some reliability assessment. There are some methods for reliability assessment also available. Right? Standard methods are available. I'll tell you. So again, it's a popular method is not such kind of popular methods. For that method, this test results graphs are temperature versus parameter changes. Based on that, we predict. Again, there are some popular equations. Right? So this NCTF, number of cycles to failure. Right? This is the main parameter. To make a decision. Again, I told you the reliability test. There is a model, CAPS 2018 model. It's a CAL PSA 2018 model. It's a remote compact metal model developed. It is like the action period of mass producers, particularly for IGBT and MOSFET, which was introduced in model was forward and system control. That's the reason we have this name. Okay. So here the purpose is to reduce the junction temperature. Junction temperature you have to predict when you apply the current and voltage at steady operations. It is the acceleration, right? Right. So, second as I told you, replacing that inverter from the EV and keeping for solar after performing all the tests. What is that test we have done? We have done two cases. One is acceleration, another one is with constant moderate speed, right? And current everything we have monitored. We understand for acceleration there is a violation in the temperature. For other cases it's okay. So now we understand that it can be used for solar systems. Typical solar system, solar panel, DC converter MPPT where maximum power point charging is implemented. After that, DC is converted to AC and converted to the grid. So all grid system, right? Here it can be used, and here there are so many types. Here I have used one DC converter and one inverter. There are some cases what they will do is so many arrays, and each there will be different DC converter, one inverter. It's no spin inverter. Separate inverter also can have. It's like connection. There are many types are available. And for that also it is tested for some standard UK power cycle. In electrical engineering, time versus power consumption we call it as a demand cycle. For UK they have taken 24 hours demand from their house. For that it has been tested after replacing the solar system, right? For 7.5 kW system. It is doing well and nowhere the temperature increased and efficiency also reasonably good. Now when power converter efficiency will be more than 90%. Let's do that. So again, time versus junction temperature. This is the main thing because we know that as aging, in power converters, thermal resistance will change, will increase in fact. So it will be shown that degraded EV traction converter is not only capable of high operating efficiency in PV application but also can potentially have long life operating life. There are three reasons why degraded automatic EV converter may have long life with good efficiency as repurposed PV converter because reduced average power demand. Average power demand is less compared to EV and reduced temperature of power cycling frequency and unidirectional power flow here. Right there, in electric vehicle, bidirectional power flow regeneration is mandatory. And reduced average power demand, detailed explanation for that why it is so. And reduced temperature, obviously, is known in detailed explanation is available. Unidirectional power flow. Power flow in power converters in unidirectional while that through EV converter is bidirectional. Same mentioned earlier. And so the life assessment model is popular open license model, and it is minor means another one. In fact, in the equation whatever I have shown, it is a combined version of both. It's a reliability second reliability analysis. In fact, so the process for second life assessment for EV power model repurpose of purification. What are the different processes we have made? This detail is there. So what are the main process? The temperature cycle, temperature versus current versus temperature gap is more important. Normally in experimental you can get. Or thermal model also can give this. Based on junction temperature profile only we do all those things, right? So what is this power demand for the solar system? Like 24 hours, what is the power demand? And this is nothing but junction temperature of the IGBT. And this thermal model will give you predict this junction temperature, right? So this is a complete flow how the repurposed purification is adapted, how it is performed. And detailed data are available here. So when you test in the solar system, different power values varies every how the temperature varies in Kelvin and percentage consumption of daily and number of failures vehicles and all tested or exhaustively tested. So reusability of end-of-life electric traction converter in solar application. Theoretical framework, what is that? First we have model thermodynamics. Then we have to test it for steady operating conditions as well as acceleration cycle, European drive cycle, for assessing efficiency, reliability, everything. Once that's done, we can fix the integrity. 100 kilowatt when inverter will be used for 50 kilowatt solar application like that. With the next PV application, using profile, traction inverters are subjected to significantly higher thermal stresses compared to PV inverter. Thermal simulation and reliability modeling in this study have shown that PV converters with 60% higher electrical thermal impedance are still counted. So, thermal resistance instead of 1 degree per bar, if we use 1.6 degree per bar, such a low problem, we can use it for 60% aging also no problem in terms of thermal resistance. Right? Due to significant derating in the side life application, it is also shown that efficiency of PV energy conversion remains high at over 98.5%. So in solar system, but in EV it will be less than 82 or 91. This is important since similar performance levels are available from new dedicated converters. Estimating lifetime in the second life application is more complicated. Second life is okay, its efficiency is okay, capability is okay, but how long I can use this is again complicated. We should have experience on that. As it depends on whether the model is in median or non-median application, we don't know. Right? More research is needed to find the life in the second phase. Okay, we can see some keywords like I told you already, circular economy, end of life management. With respect to power products, power and building block, right? And its second life management. And these are the some references. JFM in electric vehicle traction inverter, circular economy in power electronic industry, innovative design strategy. Repurpose electric vehicle battery for power and second life electricity grid. Again, very important. Like battery is given second life storage, grid storage, and this is from light to repair. This is a law, something related to law. Willingness to repair, exploring the consumer perspective to protect life essential. So it is something. It talks about the regulation, how it can be done. Right? See, from right to repair to willing to repair. Okay. So in that it says you have to reuse and foresighting lifetime investigation under low temperature ceiling and 50 years load again this is a good paper. This is a paper I have taken more second life potential. So you can read it finally. So only thing is detailed assessment, those equation and data we will discuss. I hope you will apply this in real life, in your life as well as your field. Okay, thank you. Anything we will discuss? We will discuss. Okay.
Thank you very much, sir, for the useful and powerful session. Since very faculty is not attended, and the attended faculty less to take the class. Anyway, sir, you are very well under the slides. Initially, I thought sir is very expert in power electronics, so power electronic converter of EV. That means already covered very people covered power electronic converter. They are taught even yesterday. Our Indian professors and all. So, sir changed after seeing all the title, changed and a very relevant one. Circular economy in electrical and electronics is very important. Since electrical and electronics components are the stress for all waste management, e-waste management, especially power electronics. So he explained lot of avenues, opportunities, ways for power electronic components, life cycle assessment, second life. So it's a really very eye-opener session. On behalf of all the members present here and our college management, we extend our sincere thanks and a small number as a total of us. So I sincerely thank all the faculty members. You are sitting up to the end, so thank you so much. Tomorrow we will start at 9:30 a.m. morning session. Then afternoon the feedback session, multiple choice question, there is a assessment test, all things we do. Around 3 o'clock we start the validation, 4 o'clock we have. So tomorrow, validate our class will complete all of our activities. So thank you so much. We'll be talking about